morning to all. Today we'll see the problem of toss of hanoi. It's an important problem in C, toss of hanoi. Basically, this toss of hanoi is implemented with the help of functions concept, especially the recursive function. Then what is meant by function? Function is a self-contained block of statements. With the help of those statements, we'll execute the program. Then what is meant by recursive function? A function called by itself. Function called by itself is called as recursive function. Now, toss of hanoi is the example of recursive function. Toss of hanoi is the example of recursive function. Now we'll see what is toss of hanoi. Toss of hanoi, T-O-H. In the toss of hanoi problem, we have 3 rods, or also call it as towers, or also call it as pegs. So we have 3 rods. The problem is we consider 3 rods. On each and every rod or tower we have discs. These are also called as plates. Now here we have to move these discs from source to destination. Source to destination. Among these 3 rods, the first one is the source and the last one is the destination, and the middle one here we'll call it as auxiliary. Source, auxiliary, destination. We have to transfer these discs from source to destination with the help of auxiliary, middle tower. Now, disc, where we have to place the disc? Initially 3 rods. Let us assume disc 1, 2. Let us consider source as the A, auxiliary as the B, and the destination as the C. Now we have to move the disc from source to destination. But if you want to move from source to destination, in the toss of hanoi problem, we have to follow some rules. Those are, first rule is only one disc should be moved. The first rule is only one disc should be moved at a time. This is the first rule. And the second rule is based on the size. Based on the size, higher disc should be placed on lower disc. That means based on the size, the higher disc should be placed on lower, higher disc should not be placed. Higher disc should not be placed on lower disc. That means if you have 2 towers means disc 1 and disc 2. The larger one is disc 2, whereas the smaller one is disc 1. That means on lower disc not possible to place higher disc. On higher disc possible to place lower disc. This is the second rule. And the third rule is only topmost disc should be moved. Third rule is only topmost disc should be moved. And the fourth one is all discs should be moved from source to destination with few moves. So these are the 4 rules. With the help of these 4 rules only, we have to transfer disk from source to destination. The first rule is only one disk should be moved at a time. Second one is based on the size, higher disk should not be placed on lower disk. Third one, only topmost disk should be moved. And the fourth one, all disks should be moved from source to destination with a few moves. Now we'll see with the example. Let n is the number of disks. Number of disks or plates, whatever it may be. Now let us assume we have only one disk. We have only one disk. Then the tasks are, let us assume A is a source, C is the destination, and B is the auxiliary. We have only how many disks? One disk. So if you are having only one disk, then it's very easy to transfer from source to destination. So the iteration is, iteration or recursion, whatever it may be. The iteration is move disk 1 from source to destination. Source to destination. That means the towers is A, B, C. So we have only one disk. So we can directly, without help of auxiliary, we can transfer from source to destination. This is one example. The example is, if you have only one disk, we can directly move or transfer from source to destination. Now consider second example. Let n equals to 2. N is nothing but number of disks. Now the disks are 2. Now the task will be source A, destination C, auxiliary B. 2 disks. So disk 1, disk 2. Remember, disk 1 is smaller than the disk 2. Now here we have to move from source to destination with the help of auxiliary. Why? Because we are having 2 disks here. So the first iteration is, this is the first iteration. In the first iteration, move disk 1 from A to B. Why? Because we have to follow the rules. Suppose if we transfer source to destination, then 1 will be entered into the C. But the rule is, according to the second rule, based on the size, the higher disk should not be placed on the lower disk. So that's why we have to transfer from source to auxiliary. Then the task will become like this: A, C, B, disk 2 as usual. Then we have to transfer from disk A to disk B. Right. Next, in the second iteration, what happened? We have to move disk 2 from source to destination, that is A to B. Now the task will become A, C, B. We have already on B 1. Now transfer this A to C, then it will become disk 2. Now it's very easy to transfer disk 1 to disk tar B to tar C. Now the third iteration is move disk 1 from B to C. Then the task will become like this: A, B, C. On C already we have 2. Now transfer from B to C. On B we have this one. So If we are having a number of disk 2, then how many iterations? 1, 2, 3. So with the help of 3 iterations, finally we transfer the disk from source to destination. Now third example. If we are having a number of disks are 3, then the task of hanoi is same 3 towers. Let A is the source, B is the auxiliary, and C is the destination. How many? 3. So last is 3, 2, 1. Right? Now we have to move from source to destination with the help of auxiliary. Now the first iteration, move disk 1 to move disk 1 from A to C. Then the task will become A, B, C. So which one? Disk 1. So we have to transfer from A to C. So 1. Then the remaining comma 3, 2. Now in the second iteration, move disk 2 from C to second disk, no? So A to B. Now the task will become A, B, C. On C already we have first disk. On A we have third disk and second disk. Now we have to move the second disk from A to B. This is second iteration. Now we'll see third iteration. In the third iteration, move disk 1 from C to B. Then the task will become A, B, C. C to B. On B already we have 2. C to B is nothing but 1 we place. Third as usually on the disk A. This is a third iteration. Now fourth iteration is move disk 3 from A to C. Now the task will become A, B, C. Disk 3 to from A to C. So on B common, on C we place 3. Now fifth iteration. In the fifth iteration, move disk 1 from B to A. Then the task will become A, B, C. On B we are having 1, so we'll transfer 1 here, as it is 2 here, and here 3. In the sixth iteration, move disk 2 from B to C. Observe carefully, each and every time we have to follow the rules. On C already we are having 3, so possibility to place 2. On A we are having 1. Now sixth iteration finished. Seventh iteration. In the seventh iteration, move disk 1 from A to C. Then the task will become A, B, C. On C already we have 3, already we have 2. Now we have to transfer from A to 1, we have 3. So this is the last iteration. At the stage of last iteration, finally we got the solution of task of hanoi. The initial problem is, here we assumed number of disks are 3. 1, 2, 3. So as we have to transfer from source to destination. In this way we can consider the plates n equals to 1, 2, 3. We can consider more than 3 also. So by considering all these examples, final conclusion is, now we are going to try the coding part of this. First we'll write the algorithm. First we assume n equals to number of plates or disk. So let n equals to 1. If n equals to 1, directly we move the disk from source to destination directly without help of auxiliary. Why? Because we have only one disk. Now second case, suppose if the number of disk more than 1. If more than 1, with the help of auxiliary we have to transfer the n minus 1 disk from source to auxiliary. We have to transfer first source to auxiliary by using destination. Next, in the third step, move. So after this we have only one disk on the source. So move disk from source to destination. And this process should be repeated each and every time. Next, what happened? Move n minus 1 disk from auxiliary to destination by using source. This is the algorithm of task of hanoi. So first we have to assume n is the number of plates or disk. If disk are only 1, then we can directly transfer from source to destination easily. Suppose if it is more than 1, then the number of iterations, each and every time we have to pick one and place one. So move n minus 1 disk from source to auxiliary by using destination. Next, after completion of this we have only one disk, so move that disk from source to destination. The iteration should be repeated. So after that, the n minus 1 disk from auxiliary to destination by using source. Without violation of rules, here we are going to be implement. Now we'll see the coding part of this. So first in the coding part we have to assume the number of plates n, need of source, need of destination and need of auxiliary. So we need to consider the function name. Let us assume the function name is TOH, task of hanoi. So first number of plates as tisly. Next, source. What is the source here? A. What is the destination? C. What is the auxiliary? What we assume? B. So this is the function. Now we'll implement the normal C program with the help of this. Header files, hash include, those are all common. Now void task of hanoi TOH, number of plates in integer, then source in character, destination is also in character, auxiliary is also in character. This is the function declaration. Now void main, we have to follow the order. This indicates the number of disk. The first one is a source, second one is a destination, third one is a auxiliary. Okay, now we'll write the program. So number of plates n, CLR SCR is used to clear the screen. Now first of all we have to enter number of disk. The disk may be 1, 2 or 3, more than 3 also. And with the help of scanf we read that why percentage D we used is nothing but n is a integer. So percentage D comma ampersand n. Now call the function TOH. What we have to call? First number of plates n. Source we assumed A. destination we assumed C, and auxiliary we assumed B. Now we'll call the function. So when we call the function, it will enter into the definition part. So here void and TOH in the definition. These are all actual arguments. Now we'll write the formal arguments. Int n, let source is the S and destination is the D, and auxiliary is the AX. Don't put semicolon for this. Why? Because this is a function definition. The following statements has to be executed. Now, what is the first condition? What we consider in the algorithm? If n equals to 1. If n equals to 1, what happen? We'll transfer the disk from source to destination directly. So, if n equals to 1, directly will printf move disk, percentage d is nothing but it will give the value, move disk from percentage C to percentage C. That means number of disk n, source S D, and up to this it has to be ended, and after printing of that will return. This is what if n equals to 1. Now if more than 1, if number of plates more than 1, then we have to call the function recursive, TOH. Now the second step is n minus 1. If more than 1, n minus 1, source, then auxiliary, then destination. Observe carefully here. N minus 1 indicates that we have to follow the order. What is the order? Number of disk, source, destination, and auxiliary. Now here the destination we assumed initially auxiliary with the help of destination. So here source to auxiliary will transfer with the help of destination. So then what happen after this? It will display move disk percentage D from percentage C to percentage C. So disk n, source, destination. Then after this the remaining one, again n minus 1 comma, will transfer auxiliary to source with the help of destination. This is very simple program. After declaring the header files, call the function, let us consider the function name as TOH. We have to pass the arguments as first number of disk, source, destination, auxiliary. Then void main, initialize n. N is nothing but it's used to represent the number of disk. CLR is used to clear the screen. We have to enter first how many disks we have to move from source to destination, and that numbering is stored in variable n. Now call the function. Here we assume the function name as TOH. N is a number of disk. Here A is act as a source, C is a destination, and B is a auxiliary. Then gets H. When we call the function, the compiler automatically entered into the function definition part. So in the definition, these are the actual arguments and these are the formal arguments. N, S is a source, D is a destination, and AX is a auxiliary. If you are having only one disk, just transfer those disks from source to destination directly. Return. Suppose more than 1, then n minus 1, source, this is a destination. Now the auxiliary will act as a destination with the help of auxiliary. Now the auxiliary will become destination. Then printed that this has to be called by itself. The iteration has to be repeated. So again n minus 1. Now we transfer auxiliary to, now here the auxiliary will become source, destination is a destination. Now source will become auxiliary. Now here source is a source, auxiliary will act as a destination, destination will act as an auxiliary here. This is a simple program. Now we'll see output of this program. First it will ask enter number of disk. Suppose if we enter only one, then what is the output? If you are having only one, then it will display move disk, how many? 1, from source to destination. What is the source here? A, to destination C. It will display. Here we use arguments SD, no? So it will display SD like this. This is the first output. Now let us assume enter number of disk. Let us assume here I enter 2. Then it will display move disk. So here the example is here we entered 2. So it will display move disk 1 from source to auxiliary. Next, move disk 2 from source to destination. We use the variable S. Next, move disk 1 from auxiliary to destination. In this way, we transfer number of disk from source to destination. This is a task of high problem. Thank you.